Hey everyone, today we're going to talk about solving trig equations. Before we can talk about this, which is a big concept, we have to talk about this, which is a small concept. The period of something is just how long it takes before it starts to repeat. Remember how sine will eventually repeat and cosine will eventually repeat and tangent will eventually repeat because there's multiple things that have the same sine and same cosine and same tangent? Well, that's just called the period, how long it takes before it repeats. We will spend a lot of time talking about this in terms of graphs. But for right now, I need you to know this. Sine and cosine and the reciprocals, secant and cosecant, have a period of 2 pi. Whereas tangent and cotangent just have a period of pi. That means that if an answer is correct for sine, it will also be correct 2 pi later. Let's talk about trigonometric equations. These are all equations because they have equal signs in them. This one is always true. You should know this one. It's an identity. But these two are not always true. They're only true sometimes, depending on what your theta is, what your angle is. We're going to solve for theta. Let's try one. Okay? Sine of theta equals 1/2. Well, algebraically, how do I get rid of sine? You can't divide by sine because it's not sine times theta. It's sine of theta. So what gets rid of sine of theta? Well, sine inverse does. I did the sine inverse of both sides. Over here, these cancel out, and I just get theta. Here, though, I have to think a little bit. Give me 2 angles on the unit circle. 2 angles on the unit circle that have a sine of 1/2. Well, the one that's most common is this one, pi over 6. And normally, if we just had this, if this was all that was written, we'd only give one answer. But I need to give 2 answers because there's actually 2 answers. Where else? Where else is sine positive besides the first quadrant? Sine is also positive in the second quadrant. Well, what is the same thing as pi over 6, but in the second quadrant? 5 pi over 6. Now, people have trouble with this, so I want to stop for a second and kind of talk about this. Why does this problem have 2 answers, but in our last set of notes, we only said that this one had this answer? It's because this is an equation, but what we did last time were just expressions. Let's compare it like this. What's the square root of 9? Well, hopefully you know it's 3. But if I ask you this problem, and you said, well, Mr. Ratliff, you need to take the square root to cancel out squared, and I'd say, good job. But the answer is plus or minus 3. This one only has one answer because it's just an expression. I'm not asking you to solve an equation. Here, there's actually 2 answers that will answer this question. Back here, there are 2 answers that will answer this question. 2 places on the unit circle. But those are not the only places on the unit circle. Those are just the places that are within standard form. It'll also happen every time these things repeat. How long does it take for sine to repeat? In other words, what is the period of sine? It's 2 pi. So every time we go by 2 pi, we're going to repeat. So I need multiples of 2 pi. The way we write that is 2k pi, meaning that this is the answer, plus 2 pi, plus 4 pi, plus 6 pi, plus 8 pi, plus 10 pi. Same thing here. If that confuses you, just remember this. If you have an equation, you're going to have at least 1, maybe 2 answers, plus the period times k. Let's solve this equation. How do I get rid of tangent? I'm going to do the arctan, or the inverse tangent of both sides. There is no place on the unit circle where there is a tangent of 2. So we're going to use the calculator. And I'm going to tell you it's about 1.12. I saved you some time. But that's only one answer. I need all the answers where tangent is of 1.12. So how often does tangent repeat? Well, tangent repeats every pi. So I'm going to do 1.12 plus k times pi. Not 2k pi, like last time, because the period here is only 1 pi. Let's try this one. Before I get into it, let's talk about the period. What's the period of this thing? Well, it's pi units. Okay, so let's solve it. Tangent square of theta equals 3. Let's take the square root. Tangent of theta equals the square root of 3. But I took the square root of both sides, so it has to be plus and minus. So let's write these as two separate problems. Tangent of theta equals square root of 3. Tangent of theta equals negative square root of 3. Where does tangent of theta equal square root of 3? Well, hopefully you know by now that this is the point pi over 6. I'm sorry, pi over 3. And for the negative, it's negative pi over 3. But those are just two possible answers. I want all the possible answers. So I need all the repeats. Well, how often does this thing repeat and this thing repeat? Remember, k is there for the repeats. It only has a period of pi. So there's all of the answers. The two that are in the domain of the restricted inverse function, and then the two that are, and then everything outside it. Again, remember, when you have an equation, you're always going to have plus 2k pi or plus k pi at the end of it. How about this one? This one looks really ugly. Well, if I were to rewrite this problem like this, instead of calling it cosine of theta, if I just call it c, what type of problem is that? It's a quadratic. We would solve it by factoring it, and that's what we're going to do here. We're going to factor this problem. It factors as 2 cosine minus 1 and cosine minus 3. So now we have two baby problems. 2 cosine x minus 1 equals 0. Cosine of theta minus 3 equals 0. So if I add the 1 and divide by 2, I get cosine of theta equals 1/2. If I add the 3, I get cosine of theta equals 3. You should know that this does not have a solution. Why? Because cosine of theta is always between 1 and negative 1. So it'll never be all the way up to 3. I don't have to solve that side. On this side, where on the unit circle does cosine have an answer, or what angle has a cosine of 1/2? In other words, which point has an x value of 1/2? Well, there's two of them. It's 1/2 comma square root of 3 over 2, and it's 1/2 comma negative square root of 3 over 2. Oh, hold on, that's wrong. Where does cosine equal 1/2? It equals 1/2 at, what is it, pi over 3? And the other place that it has cosine of 1/2 is 5 pi over 3. Those are the two places on the unit circle that have cosine of 1/2. But that's just two of the answers. I need all of the answers. So it's going to be plus k times something. Well, what's the period for cosine? 2 pi. So that's why I have two answers. There's two places on the unit circle where the cosine of theta is 1/2, and plus all the repeats of it. I realize this is hard, guys. Inverse trig functions and solving inverse trig functions are probably some of the toughest things you'll do this year. Just remember, if you know the unit circle and can think backwards, you'll be fine. Don't forget how to factor. Don't forget, especially higher order factors, like that would be a slide and divide problem or cubic problems. Don't forget your identities about sine squared plus cosine squared equals 1. If you remember all of that and can put it all together, you'll be fine with this.